Alright, I can't speak very loudly. I'm in a doctor's office, but I'll do my best. Okay, so for problem number 1, you can see I've got this template up here. We're going to do these problems the same way every time. So anyway, for problem number 1, we've got, oops, I meant to get blue. We've got f of x equaling 3x minus 1. Okay, so over here in the work area, we've got f of x equaling 3x minus 1. And that means that f of x plus h is 3 times, since x plus h is the input, we have 3 times x plus h minus 1. And we can simplify that. Equals, can distribute the 3 times x plus 3 times h minus 1. So I'm going to underline our f of x plus h, and I'm going to underline our f of x. Okay, now we're going to put those back in the difference quotient. So we're going to try to find here f prime of x. We're trying to find the derivative. Oops. So I'm trying to find the derivative. We put f of x plus h in first. That's going to go right here. Then we're going to subtract our f of x. Okay, I need to write small. So 3x plus 3h minus 1 is this guy. 3x plus 3h minus 1, and then our 3x minus 1 goes there. So that's our f of x plus h minus f of x, and now we just have to simplify. Okay, and we're going to do that. What color should we use? Let's use blue again. Okay, so we have equals the limit as h goes to 0 of, you can see 3x plus 3h minus 1. Distributing the minus, we get minus 3x plus 1 all over h. And keep in mind, every time you do this, any term that doesn't have an h in it is going to cancel out. So we get 3x minus 3x, those cancel. We also get the negative 1 and the positive 1 canceling. And so we end up getting equals the limit, and I want to see you write that every time, as h approaches 0, of 3h over h. And so those h's are going to cancel as well, and we just get 3. So the limit as h goes to 0 is 3. Therefore, we say the derivative, let's do that and let's be good about that. So therefore, f prime of x is equal to 3. Okay, and that's the answer. It's okay for the derivative to be a constant, and you're going to see why that happens more often. Okay, so that's the first one. Now for the rest of these, actually for number 2 I'll walk you through it, and the other ones I'll just show you the total solution. Okay, I got to go back and see what are we doing here. So 2x squared minus 3x, so our f of x is 2x squared minus 3x. 2x squared minus 3x. Okay, so that goes there, and we try to be really professional, minus 3x, and put it in 2 places. And so our f of x plus h is 2, I need more room here, something squared minus 3 times that something. Okay, and again, that something is your x plus h. So your x plus h goes right there, and right there, because that's what it says. It says whatever the x is, you're going to square it there, multiply it by 2, and then you're going to subtract 3 multiplied by that same number. Okay, so we've got it there, and we've got it there. Now we just have to simplify. Okay, so 2 times the quantity x plus h squared is 2 times x squared plus 2xh plus h squared, okay, minus 3x minus 3h. Okay, so we get 2x squared. We're going to distribute the 2 now, plus 4xh plus 2h squared minus 3x minus 3h. So that whole thing is our f of x plus h. And we're just going to replace f of x plus h with that whole thing and our f of x. So this is going to be not enough room here, so I'm going to put down here it equals the limit of, as h goes to 0, of this whole thing. It's going to be a big, long expression. And it'll be 2x squared plus 4xh. So we have 2x squared plus 4xh. Okay, plus 2h squared plus 2h squared. I have to keep going back and forth. Minus 3x minus 3h. Minus 3x minus 3h. And then minus our f of x. And our f of x is 2x squared minus 3x. 2x squared minus 3x. Okay, all of that is over h. Okay, so unfortunately we're going to have to do this one more time, but maybe we can take a little shortcut here. This is going to be minus, let's do it in a different color, then it'll be easier. Minus 2x squared plus 3x. Okay, so I've eliminated that. I didn't have to rewrite this whole thing. Now I can cancel some stuff. 2x squared, I know that's going to cancel with something, minus 2x squared. The negative 3x is going to cancel with the positive 3x. And then I'm just going to collect any like terms, but I don't have any. And so basically what we have here is the limit, as h goes to 0, of 4xh plus 2h squared minus 3h. Okay, all over h. Okay, and so we can cancel an h if we factor it out of the numerator. So let's go ahead and do that. Let's factor out the h, and we get 4x plus 2h minus 3 all over h. So that's the one we said, okay, well we can cancel that, cancel the h, and now that the h's have been canceled, we can substitute h equals 0 in for h here, and we get 4x plus 2 times 0. Sometimes students forget to actually put that h equals 0 in there, and they get something other than what I just got, but this is equal to 4x minus 3. And that's what the derivative of f of x is. So f prime of x is that. And if we want to get really professional, we say, therefore, we don't have to do this. F prime of x, I'm doing this so you can see exactly what's going on here. F prime of x equals 4x minus 3, just to make sure that you can see the big picture. That's what we were trying to do. We were trying to find the derivative of f of x if f of x is 2x squared minus 3x. Okay, so there you go. I'm going to pause the video and work out numbers 3 and 4, so then you can just do those on your own and just check the answers. Okay? Alright, well, here you go. You've got your answer right down here for number 3. That's the derivative of 1 over x. And the next one, this was kind of tricky, and I apologize for giving this to you, because there would probably be no way, unless you used your calculator, that you could figure out this limit, or sorry, this derivative using this limit right down here. And just keep in mind, this limit right here, let me back up one step. This e to the x right here, if you ever get any sort of a term or a function in there that has nothing to do with where h is going, then you get to bring that out in front. Okay, so that's why I brought it out here, e to the x times the limit, and this limit right here is just 1, as you can see right there. And I also included a graph of the function, e to the x minus 1. Sorry, I got interrupted. The graph over here of e to the x minus 1 over x, you can't see it, but there's a hole in the graph. Like I said, you can't see it, but let's see if we can make that better. Just pretend there's a hole there. But the limit is 1. Anyway, you wouldn't necessarily be doing this except on a calculator, so understand how to find limits on the calculator, and you can easily derive derivatives. Derive derivatives. That's interesting. But anyway, there you go. I'm sure that that was not an easy one for you unless you were clever enough to take your calculator out. So I will see you in class. Have a great night.